Welcome everyone, I'm Adrián Mezei from SnapSoft Ltd, and I brought you a very recent and trending topic for today. This is serverless technologies in AWS Cloud. Let's have a quick look at the three topics that I will talk about. In the first section, there will be a few AWS services that I will show you that you can use for serverless infrastructure. Then I will have an example application as an architecture overview so that we can see how the services can be connected together. And in the end, for the third part, there will be an infrastructure as a code, and we can see some elements of this application and how these are connected. So let's start with the first part, serverless services. What is serverless services? When we think about serverless, we have different things in our mind. We think about quick deployment, going to production very fast, using services that are managed by the cloud provider. We don't want to deal with the operating system. We don't want to configure the scale of our application. So we basically would like the cloud provider to basically handle these surroundings for us. So when we go serverless, we try to use services that are managed by the provider. What is managed? For example, the container, the infrastructure behind it. And here we also would like to pay, for example, after there is a certain load. So we don't want to over-provision. This can also be solved by serverless. I have also listed a few things here that we need to bear in mind when we develop an application and the architecture behind it that is serverless, because usually we need to design our application to be stateless and to have the possibility to use the services in a stateless manner. And this is very important because usually this is a decision that we make at the beginning of our planning. And when we use these services, I will show you, basically there will be three categories of services: the compute, the data storage, and some integration, application integration services that we can use to wire together the components of our application. And of course, we call this serverless and we use serverless services, but actually we have servers in the background. This is just not our task to manage. These are basically offloaded from us, and it's handled in the background by the cloud provider. So here I will show you the three categories that I've just mentioned: the compute, the data store, and the application integration part. And I will talk about some of these services, and I will also show you some of these in the next section. So let's start with the compute part. Basically, if we go to a cloud provider, we can choose from basically three different levels of abstraction that we would like to obtain. The first is the very basic, when we get an instance that the cloud provider manages the hardware, and we get the whole operating system. We can do anything with it. We can also configure auto-scaling for these, so there will be multiple instances running from the same image. So we don't have to think about the scaling. At least we need to configure it, of course, but we don't have to manage the underlying hardware. The second level is the container level. At container level, we don't have to manage the operating system. We don't have to think about how we design the background, what software there will be installed, because we only have to deal within the container. And the container is given for us in AWS Fargate, for example. Certain containers can scale within pre-configured boundaries, and the cloud provider manages this for us. And there is the third level, which is the function level, function as a service level. Here we don't just get the container itself, but we get an execution environment as well. We get the runtime, and we don't have to configure that as we would do it with the containers. Of course, we can configure environment variables and logging and permissions and a lot of other things, but here we have a lot of pre-configured defaults. And here you can also see a categorization. I also put the on-premise group here because it fits to this table. So from left to right, if you go in the first column, everything is managed by you. Basically, you own the data center and you manage everything. In the second column, you don't manage the hardware. So basically, you obtain an instance, but it's virtually running somewhere. In the third column, the container as a service, and now we are at the serverless part. Here, the underlying operating system is also managed by the provider, and you only need to think about your containers. And finally, there is the last column, the function as a service, and here also the container is managed by the provider, and you will also get runtime. So basically, you put your application code, and of course, you need to configure an entry point specific to the execution environment, but then you are good to go. So, which should we choose? Both of them are serverless, the container as a service and the function as a service. Both of them are serverless. In most cases, both of them can be a very good solution, and both of them would work for most of the projects, but there are differences. There are boundaries, there are limitations that we need to think about when we decide between these. For example, when you design an application in a containerized manner, then you will have very general boundary for your application, because if you have your application containerized, you can move it to another cloud provider, you can move it to your self-hosted instances because the containers can be executed there as well. It is not cloud provider, you are not bound to the cloud provider. So this portability is, for example, a point that you can decide. Also, there is, for example, when you would like to do some event-driven functionality, then it's usually very easy to go with the cloud function, the Lambda function, and the function where you get an execution environment, because the cloud provider already configured these interactions for you within its own services. But then these event-driven execution parts will be probably bound to your cloud provider, and if you change the cloud provider, you need to probably re-implement or just a bit modify your solution, the code itself. Also, there are a few limitations, for example, for AWS Lambda, because you need to think about these. The memory, for example, cannot exceed approximately 10 gigabytes. And if you require more for your execution, then you cannot go this way. If you, for example, would like to have an execution time longer than 15 minutes, then also this is a boundary that will not allow you to use in that scenario. So basically, when you have the possibility to use, for example, AWS Lambda, then this function as a service way is very convenient and usually very easy. So that's from the compute. Let's have a look at the Datastore solutions. So in Datastore solutions, we basically can think of 3 serverless ways that we can use. There is the object storage solution, which is provided by Amazon S3. There is the DynamoDB, which is a NoSQL database solution. And there is RDS, which is a relational database solution. In some applications, maybe you will use all of these, maybe some of these. A relational model is coming from a more evolved or has a larger or longer future, and it's more evolved in the software development history. When you go this way, for example, the relational database way, you will probably have some more upfront commitments that you need to make, because there will be an instance running in the background. Of course, you can scale it down. You can sometimes even scale it down to 0. But in most cases, if you would like to have it up and running, you will have to pay for it on an hourly basis. If you, for example, use a NoSQL solution, for example, in this case, DynamoDB, DynamoDB provides you a way where you need to only pay for example, the requests. And this can be very comfortable in some use cases, because when there are no requests, then you don't have to pay for it. And your requests go up. DynamoDB can scale up, and it can provide you a single-digit millisecond performance at scale. So this can be a very comfortable thing to use, where you don't have to think about how you provision the background and the infrastructure behind it. S3 is an object storage solution. It can do a lot of things. You can configure versioning, for example. You can have different lifecycle policies. You can have different storage classes. You can store large files. You can store for long term, where you get some price reductions. And it is very, very complex, and you can do a lot of things with it. You can even host a static website, which is a very convenient way to do so. So the interesting part here is RDS, how the whole relational model is created and how the infrastructure is provisioned for you. There is a diagram here where we can see that with an architecture, if we use AWS Aurora, here we will get an auto-scaling, basically infrastructure in the background. So it will scale itself, the compute load will be scaled, the storage will be scaled, it is highly available and durable. So this can be a very easy way to go. Of course, it has the pricing consequences. And let's talk about the application integration part. So when you would like for example, your Lambda function to be accessible over the internet, you need to provide some kind of gateway for it. You need to somehow make it accessible through the internet. So you usually put, for example, API gateway in front of your Lambda. The easiest way here is to go with an HTTP API that you basically put in front of your Lambda, and you simply direct certain requests, certain path elements to your Lambda function. But you can also direct it somewhere else. A lot of AWS services are wired together with API gateway, and they can work smoothly with them. Because, for example, if you'd like to have a file upload, a file download, you can wire API gateway to Amazon S3. And if you have this connection in API gateway, you can configure a lot of things. You can configure authentication, for example, authorization, either to your own user pool, or you can even set up your own Lambda function that will do the authentication, the authorization for you. If you go the REST API way, there you get even more functionality, and it's even a bit more complex. So here, for example, you get API keys that your endpoints can be requested with, and you can configure certain thresholds. For example, you can configure for a specific API key that you would like to have only at most 10 requests per second, and you don't allow more than that. This can be used, this can be configured with REST API very easily. And you can also configure WebSocket connections. WebSocket connections will be maintained for you by API gateway, and then you can do some processing in the background and ask API gateway to send your messages back through the WebSocket connection. And this is also a very, very comfortable way to go, and there will be an example for this later. In the application integration part, I brought you three, I think, important services. Here, the step functions, the simple queue service, SQS, and the simple notification service, SNS. The step functions are, it's a very convenient service that you can use to visualize your workflows. When you have multiple cloud functions for an application, how they trigger each other, how they invoke each other, which are executed, what is the flow of your logic, can be visualized with step functions very well. When you would like to decouple your application, you can do it with SQS, simple queue service. Here you can have managed queues. You can put your events to the queues, and you can have on the other side a processing, for example, Lambda function running. So you can use queues, you can create, you can use this managed queue to decouple your application. And you would also, in a lot of use cases, use SNS, because in SNS it's a notification service. So here you can have topics, you can have subscriptions to specific topics. And when you publish a new event to a topic, then all those who are subscribed to this topic will get a notification. For example, you have a newsletter topic, for example, you publish a message to a newsletter, and all the subscribers will get an email, for example. If you configure a threshold for certain errors in your application, then you can wire this to SNS, and for example, your developers can be subscribed to this topic, and if a certain level of errors are reached in your application, then for example, you can get a push notification. So you can use the application, these application integration elements to decouple your application. And let's have a look at the infrastructure as a code part. A lot of these elements that I have shown you in the previous slides, I will have an architecture where we can have a look at how these are wired together. Infrastructure as a code is when you write your infrastructure in a certain language. You can have a descriptor for it. For example, in this case, a YAML or a JSON file. And the solution of AWS for this is CloudFormation. So when you would like to go infrastructure as a code, you would like to implement your architecture, let's think about CloudFormation. CloudFormation provides you a way to describe the application elements in files. You can version these files, you can commit them, and you can see a versioned history of your infrastructure. Also, there is a CLI tool for it that you can use for deployment, and you can see change sets here as well. This is not a very convenient way to write these CloudFormation templates, so there is a framework built around this. You can write this code from TypeScript, from Python, from Java, or from .NET. You can use the libraries provided by AWS, and you can have certain constructs that you use here. The CLI tool will compile this back to CloudFormation template, and eventually the CloudFormation template will be used, and that will be deployed. But you don't have to write it in the first place. You only write, for example, TypeScript code, which is a more comfortable way to describe your infrastructure. So what is the advantage of CDK? It provides you 3 levels of constructs. It provides you a level 1, level 2, and a level 3 construct. Basically, if you use level 1 constructs, you can still use TypeScript, but you get a type checking. You can use your own favorite programming language. But here at level 1, the infrastructure elements are exactly represented as CloudFormation resources. So you have actually the same resources that you can provision. At level 2, you have a lot of convenient defaults already configured for you, and it's much easier to configure using level 2 constructs. It saves you a lot of time, and you can avoid a lot of boilerplate code here. So let's have a look at it. How does it look like? Here in this example, I just created a very short TypeScript example. You can see 2 buckets are being provisioned. First, they use one construct, which is, in this very simple example, not so much longer than the L2 construct, but you can see that it makes a bit more sense, and maybe it seems a bit better to use the L2 construct. And let's have a look at the application, because the application can provide you a bit more insight to how this works. Let's imagine a simple application that we call Awesome Chat, for example, which is a global chat application. You can type your message, your name, you can hit send, and it will appear at everyone else. This infrastructure will use S3 for front-end file serving and API gateway with Lambda to handle the WebSocket connection request, and it will use DynamoDB for persistence. the application elements can be visualized in this way. Static files are coming from S3, and the WebSocket connections are coming from AWS Lambda. I have put 3 components here. Of course, there are a few more elements in the background that wire these together, but these are the most important elements. So we have a cloud function with a few properties. We have the DynamoDB table that can persist our WebSocket connections, and we have the S3 bucket that can hold the static files for us. If we generate the CloudFormation template, it will look something like this. So you can see that there are a bunch of other resources that are provisioned for us, and some of these are also written down in the architecture in the TypeScript code that we wrote. So thank you very much. I just put 2 links here that you can see in the QR codes. You can have a look at the source code of this application. You can also try the application in the other link. And if you have further questions or would like to hear some more about the details of this, then see you at the expo. And I also have some references on the next slide. So if you would like to check out some resources, go there. And thank you very much for your attention.
Some questions for you. The first one is there a possibility in future to execute integration tests with local implementation in AWS Lambda?
Yeah, this is a very good question. To do this fully automated, I think there is a possibility in the future. Currently, you maybe need some kind of configurations because it can be a bit different if you execute it locally. But basically, you can have, for example, a Docker container that is running in the background and that can execute your cloud functions locally. So that you can use for execution. And AWS Lambda has the Docker container that you can use the same way that it would be executed in the cloud.
And the second question is applications that use AWS Cloud are heavily dependent on AWS. What is the guarantee that it will ensure secure and consistent operation?
Yeah, so the first part of this question is that they heavily rely on AWS, and here you, of course, because the infrastructure is presented for you by AWS, you need to read their documentation and see what measures you can have there. But of course, the permissions that you have in the cloud, it's up to you how you configure them. So for example, the permissions which resources can be accessed, the configuration is up to you. So there are certain parts where you should configure, and there are certain other parts that, for example, the underlying infrastructure, and that is maintained by AWS. So you have this shared responsibility model, and the part where you are, you should configure. That's up to you how you use it. And the other part, you really cannot do anything about it.
Thank you so much for the answers, and thank you so much for the presentation as well.
Thank you very much.